Hey, Chad. This is it. No, I'm not using that screen. I'm not using that screen. You can use either or.
Okay.
Okay, cool.
I brought the right tool to finish setting that thing up too.
Oh, cool.
So hopefully I'll remember that. These lights get warm on you?
No.
Not too bad?
Make sure you move that fan so, or else you're gonna roast.
Oh.
No, that one is not. There's one behind you that is. You may need to get like an extension. You can pull that one. If you need a power strip, there's one there, and there's one in that box as well that's not being used. Yeah.
The AT&T Wi-Fi.
Yeah, do you have that?
2E.
Yeah, get on that one.
Is there a password for it?
There is a password. Shit. Here's your password. Pardon? It's on there. It's that Z or
Oh.
let's check. Are you on?
And in order to plug in TV, these long green ones.
Here's there should be an HDMI cord there, but here's a long one.
Well, I have an HDMI cord. I need to plug it to power.
The power to the TV.
Is it green?
Yeah, use that cord. You're not gonna be able to. It ends up there. You're gonna have to find an extension cord like out of that box and plug it in over there. Those are hot. Yeah. See, you see a cord in there? Yeah, that should get you there.
Dude, you're gonna have so many ports by the end of this desert blockchain thing.
Hey, sweetie, you rang? Thanks. Yeah, I'm kind of up to my eyeballs and trying to get this thing set up. So, okay. Love you too. Okay, bye. I don't think the internet works anymore.
Well, a lot can go wrong in the world today, but if that goes wrong, we're all really good. Game over for humanity. We had a good run, but the internet went, the internet went out, and we couldn't survive.
Yeah. Okay. What am I doing here? Are you cool enough?
Yeah.
Are you all connected and everything?
Yeah. I'm trying to load up the dev net real quick.
Cool.
Just because I think I can read the file from this.
Okay, there's that. It's the apocalypse on our meetup night.
Oh, I get that.
It's back.
I'm actually joking, but the end of it, he works with power. Well, cool.
Okay. With any luck at all, this is going to work out here, chat. I'm probably going to have to turn off these fans at the outset. And it's hotter than hell in here. I do that. You want a water?
No. Let me check if I got here before.
Sent out a ton of stuff. Both the YouTube live link and the Zoom.
that go again?
Son of a bitch. Yeah, I don't know what's wrong with it.
Okay, now put it back out.
Yeah, it's back up, but flaky. Disappointing. It could be that it's getting too hot. It's really warm. Oh, me my. Time's it going to be anyway? 6:40.
Well, I got it up and running. I don't necessarily know how to use it.
The power gate.
Yeah. I got a file system instant. Oh yeah. Oh yeah.
Cool.
Yeah, I'm showing here now.
Nice. I might. Let's see how this works. That might actually work. Cool.
Okay, cool. So basically, I'm able to follow along the YouTube demo.
Oh, good.
Command for command. I got my token set up. Got my instance.
Hey, Scott. Can you hear me, Scott?
Yep, I can hear you.
Awesome. I've got some fans going on. I'm going to turn them off in a minute. I'll go ahead and do that. Let's leave yours going, Chad. Here's Andrew. Hey, Andrew.
Hello.
How are you?
Good. How are you?
Very well, thanks. Good to see you.
You too.
This is Andrew. This is Scott. He's one of our active participants in Desert Blockchain, and he is an expert in Monero.
Excellent. Nice to meet you, Scott.
Nice to meet you too.
And then I'm going to turn the camera a little bit, Andrew, so that you can see Chad over here. Let's change the picture. So, all right.
Andrew.
Hi there.
That is Chad, and he is running PowerGate on his, is it AWS?
AWS instance, yeah.
Yeah.
Oh, super.
And while we're waiting, Andrew, I've been trying to get PowerGate running on Raspberry Pi, and I've had a little trouble with that, but I think it's basically just installing Docker on a Raspberry Pi.
Oh,
So
wow.
I get
I'll be really excited to see that.
Yeah. I get this permission denied error, so we're still kind of hacking away on it.
Okay. Huh. Cool.
Have you ever seen anybody run PowerGate on a Raspberry Pi?
No, I had it on my to-do list to run. Basically, we have this other thing for our database, Threads. We have a daemon, and it's written in Go. And so I was going to try to do that on a Raspberry Pi, but I haven't gotten around to it yet.
I'll let you know when we have success.
Cool.
Is there anything in particular you'd like to highlight, Andrew? I think this is going to be mostly kind of a discussion after we run through your presentation.
No, I think my presentation will cover a bunch of different things, and then you can just open it wide open.
Cool. Chad, how's the sound on me?
Yeah.
Is the fan interfering?
Not too bad.
Not too bad. Okay, what are we doing? We don't have any air conditioning here in good old Desert Blockchain Camp.
No big deal. I'm only 115 a day.
Yeah, that's right. It's even 110 today. So Andrew, I'll just make a few introductory remarks and then turn it over to you. You can go through the presentation and then we'll just kind of open it up for discussion.
Sounds great. Let me just try sharing really quick.
It's a good idea.
You see an empty desktop currently, right?
Yep.
And then you see my first slide?
Yep. Got it.
Sweet. Cool. That's all I needed.
So right at 7, I'll start recording and I'll start the introductory remarks, and then turn it over to you, Andrew. So we are currently live streaming.
Okay. Where's the live stream?
It's on YouTube. We've tweeted it out.
I'll check
Should be
your
able to get-
Twitter. Yeah.
Yeah, check the Twitter feed. Jose, how are you?
Good evening, everybody.
This is Andrew.
You don't see me, right?
You're a little dark. That's better. Much better. Cool.
I usually prefer a darker place to work with. Not really, because it brings me some peace.
Good.
And it's no coincidence that the theme of my computers is dark.
So Andrew, Jose is with American Express and has extensive background in all sorts of computer science projects and so forth. So
Oh,
Nice to meet you.
nice to meet you too.
and Professor Marchant. Hey Gary.
Hello, how you doing, Jay?
Good. How are you?
Good.
We've got Andrew on, and we're going to start the recording in just a moment. Andrew, this is Professor Gary Marchant of Arizona State University, Sandra Day
Andrew.
O'Connor College of Law. He is a real innovator in the area of policy and blockchain, and some awesome conferences at Arizona State University. So
Very
Back
cool.
in the good old days when we could all get together.
This is good.
Yep.
that's right. This is getting together.
Different way.
Andrew, Chad's day job is in the IT department for CVS Healthcare. Just to give you a little background.
My wife's an attorney at CVS.
Really?
You work at Chad? Do you work on the building on Shea?
Yeah, I work on the Shea Boulevard. Back
Yeah.
when I used to go to work. Yeah.
Yeah.
I went and checked out the office. It's a big vacant building right now.
Yeah.
But occasionally you get called into the data center to do some hardware repair and stuff. But
Right.
other than that,
Okay, I'm going to go ahead and get started and record. Let's see. This computer. So you're probably all getting some sort of authorization to record. Well, thank you everyone for attending the June session of Desert Blockchain. This is our monthly session on the fourth Wednesday of every month. And we feature a different topic in decentralized web technologies. And tonight we're talking about textile and some really cool projects that they have going. And textile is associated with Filecoin, which is a Protocol Labs construct. And if you're not familiar with Filecoin, it is about to launch the main net in a couple of months. And Andrew will be, I'm sure, telling us a little bit about that. And I've been following Protocol Labs and Filecoin since 2015, basically since the inception of the projects. And there's a lot of projects out there, but the reason I'm so interested in Filecoin is because it is a different approach to consensus using blockchain. They're using proof of space time, and it's really creating like an Uber opportunity for everyone to become a cloud hosting provider. And it has some remarkable characteristics to it. And that's just Filecoin. The other projects associated with protocol labs like libp2p and IPFS are incredibly powerful constructs. So we have the good fortune tonight to have Andrew Hill with us, who is the CEO of Textile. And I'm going to go ahead and turn it over to Andrew. And if you just tell us a little bit about how you got interested in Filecoin, IPFS, decentralized web, and then tell us more about textile.io. Thank you, Andrew.
Absolutely. Thanks very much. And thanks for the intro. Yeah, sure. A little intro about myself. So I actually did my PhD in biology. I studied biodiversity informatics, very interested in how you could take large data sets and try to automate the generation of information that you could extract knowledge quicker. We could understand how change was happening, how the world was being impacted by things like population growth, global warming, environmental change. And but I got really interested in just how you could start to really tie data into more meaningful outputs. And so that's how I got into programming. It's how I got into databases. It's how I got into a lot of different things. And I've kind of moved around since then. And I've worked at a different startup and got really interested in how companies operate and how companies can have an impact. And I think we're at this really interesting moment with the internet and with blockchain and with decentralization, that not only is technology changing around us, but the companies and way companies are being built has changed around us. And I really wanted to be part of that. I wanted to figure out what was going on there. So my co-founder and I actually started Textile through just a series of conversations, trying to figure out, if we were kind of committed to the idea that where we could have the biggest impact in the world was through creating technology and doing things with technology. And so we started asking, where could we make an impact that we'd be excited about and interested in and think would be sort of beneficial for the long run. And we really zeroed in on data, and data on the web at the inception of Textile being very, very broken, and just thinking that there was a lot of opportunity to do things differently with data on the web, and making data a first-class citizen, and making data protected, making data last for generations, giving individuals ownership and sovereignty over their data, all these concepts that just really aren't possible on the internet as of right now. And that gets really exciting. And so I like to really think about those problems still. And I ask myself a lot of questions like, what happens when you have data sets that you want your future generations to have access to? If you think about it right now, we're living in a period of humanity where data is one of our greatest outputs, but we're letting it be locked up and controlled by the companies that have sort of the biggest shovels. And so it's a little unfortunate. And if you think a good example of that might be your genetic data. Genetic data has such clear importance for you right now, but can also have really big importance for your descendants in 1,000 years. And so who owns that, who controls that, and who ensures that it will be around for them to look at, to study, and to get information from? And so you can take that. That's a really clear example. There's other clear examples and other uncertain examples that are out there, but they're all over the place. And so just trying to figure out what that looks like. So we were drawn to IPFS and Filecoin because those technologies and that sort of family of technologies really lowers the barrier to imagine a different structure of the internet. There's, if you think about the way the internet is right now, we use the internet primarily as the network, and we use services that then provide us things through that network. Blockchain and decentralization let us really think about the internet as the actual service provider. So we can think about the internet as the place that we store our data, that we run encryption, that we run analysis, and it gives you a really interesting new way to think about what data is going to look like in the near future. And so that's kind of the origin of Textile, and we're always thinking about those ideas. We arrived at IPFS and identified it as just being early enough that there's a lot of work to be done to build a layer of abstraction on top of it that made it very easy for developers to pick up these protocols and build applications with. One of our sort of driving KPIs is speed of failure. And that works internally, of course, but what I'm talking about is for our users. I think if we want to have success in decentralization and on blockchain, we need to really reduce the speed and cost of failure for people to build and play and test and learn with these technologies as fast as possible. And so if you think about any successful consumer applications or products, they're usually sort of almost random in their success, and they come after a long line of failures. And so if you want to have success with technology, you actually need to set the scene for technologists to fail many times and do that easily without a high cost. And so we're actually just trying to set the scene for thousands of easy failures so that we can have a few really big successes in decentralization and blockchain. And so I guess in my talk, I'll tell you about some of our current technologies and where we're focused on doing that. So let me jump over and just share with some slides here. I might move through them pretty quick so we can jump to discussion as well. How's that looking, Jay? Thumbs up? Cool. Okay, so yeah, I already gave you my introduction, and I work at Textile. You can find us at textile.io. Really, our documentation page is the main place to go, and that's just docs.textile.io. Right now, we're really investing in 3 core pieces of technology, and then one sort of light piece of technology that brings them all together and gives users an easy place to get access to them. And so those 3 pieces of technology are ThreadDB, buckets, and PowerGate. And the hub is this sort of portal that we built to get people onto those technologies easily. So I'll just kind of walk through what each of those technologies are, so that the people that are watching that are trying to build things or trying to think of inspiration for the next thing they want to hack on, you maybe can pick up some of these projects. Just so you know, they're all open source. You can find them all on our GitHub. We have some pretty good documentation on that on our main webpage. And so just invite you to come try these things, test them out. We also have a Slack channel, so feel free to jump in there, and we're there every day working with people and answering questions. So if you're trying to build stuff, it's a great resource. So ThreadDB, when we first started building on IPFS, we really were trying to narrow down what were some of the problem areas that developers were going to hit. And we identified that mutable data is obviously a challenge with IPFS. So IPFS is fundamentally immutable data. It uses content addressing. So every piece of data or every file in IPFS gets hashed. That hash becomes the fingerprint or the address in the network that it's used to move around. But when you're building an application, that becomes challenging because it means you have a lot of fingerprints and a lot of these addresses and a lot of keys if you're using encryption to manage. And every time you change the data, you then need to handle how that trickles up or down and all the effects that it might have. And so a great way to abstract that for a developer would actually be a simple database where there's just data in and there's data out, exactly how you expect it. And when that data changes, you can still reference it in many of the same ways. And so we started building ThreadDB, and the reference implementation of ThreadDB is in Go. We also have a light implementation in JavaScript, but it's supposed to be a MongoDB-like interface for storing data on IPFS. And what's kind of even cooler about this is that you can have multi-user authenticated databases. So it uses the protocols in IPFS and libp2p to allow you to have multiple users editing the same table, more or less. You could think about it in your databases. And so that's done with a modular ACL. It handles some private key identities, and it allows you to sort of plug CRDTs on top of it. Some of these things are in the early stages, so ACLs are fairly limited on ThreadDB, but it's kind of like the next area where we're working on pretty rapidly. So things will be coming out there soon. So just to give you a sense of what it looks like, it should look pretty familiar to anybody who's used a database or a document store. So this would be a little JavaScript example of creating a new collection for astronauts. You define the schema for the collection, and then you go ahead and you start inserting data and querying and finding data inside of that database. So the networking piece is actually the really tricky part. When we first, so we call this version 2. It's more like version 1. I think we got started with version 1 instead of version 0. But our first version, we really just threw everything into it, trying to figure out, how would a database work in this kind of on this decentralized network. And one thing that we found is that most peer-to-peer databases, they rely on sort of all the peers being online most of the time, or they rely on a push-based update system. So a peer, so if you're a peer on the network, so if you're A in this top row, the only way that B gets your updates is if you push those updates directly to B. And if B's not online, they're never going to get those updates. And if they come back online, they're not likely to find you online again in real consumer application networks. And the reasons for that are pretty obvious. But like if you're building an application in a browser, or if you're building a mobile application, those applications are really ephemeral on the network. So mobile applications are constantly backgrounded, or the user goes offline, or the phone just goes in the back pocket. And in a browser, the second the tab is gone, all the actual compute of the application is gone too. So in Threads, we really architected a lot of ways to get around that by allowing pull-based endpoints, so B can actually pull from A. And also we layer in sort of what we call this multi-layered encryption in the database, where the outermost layer encrypts the metadata of the updates, and you can actually give the key for that outermost layer to third parties. They can't see the content of your data, but they can do relay and archiving and provide services around the updates. And so in that way, A can actually push to a third party that B can get those updates from, and they don't really care who that third party is. They don't need to trust them. All the updates are signed and verified and encrypted internally. Tons of good documentation about that. I think I really wanted to move quickly through this because I think with some things going on in Filecoin, I wanted to get more time on what we're doing there. But one more thing before I get to Filecoin was buckets. And so as we were building Threads, we realized that just like with most databases you've used, they're really good at, they're sort of optimized for the metadata or the kind of lightweight data, but you don't typically store the actual binary files in your database. And so what we built is a really good system for sort of keeping a bunch of peers up to date about changes in a data set, but we hadn't built a very good system for actually moving the raw data itself. And so buckets is a secondary technology that we built that actually uses Threads to track changes of directories of files and move the data of in those directories around. So they're dynamic folders on IPFS built on ThreadsDB. They allow you to sync between multiple users. You can do, well, they're actually only public as of today, but the pull request is out to add encrypted and password protected versions of buckets, and they're highly interoperable. So buckets are, buckets are just folders in IPFS at the end of the day. So they're UnixFS. They're also a DAG, which means that you can request them over IPFS. That every bucket you create gets its own IP NS address. It also gets endpoints on gateways, so it's HTTP enabled, and it also is Threads capable. So there's a handful of different protocols that allow you to work with buckets. And so depending on what you're building, it gives a really powerful way to move these sets of data around and synchronize changes in those sets of data. We have some great, good documentation and some good examples of how to build things with buckets on our website. I just wanted to show you this example really quick. This is the command line interface for creating a bucket. So I'm just going to create a bucket for images. Here you can see some of those interoperable formats as links. And then I'm just going to push now a folder of images. So you can see like 10 or so images, and it's actually getting pushed to a remote node over the thread database. So here I'm just going to edit one of the images with some fake data. But I made a mistake. So I'm just going to add some fake data to the image. And then if I go and push this bucket again, it's going to do some really cool little things to just optimize what you're pushing. So you see it just detected that only one of the images had changed, and then it will push that to remote. So if you've used IPFS before, you might be familiar with pinning on IPFS. And if you want to figure out how buckets fits in that, you could imagine buckets as pin sets, more or less, where these folders, you can move them to remote nodes, and those remote nodes can just track and pin and persist data on IPFS for you. So that was the command line. So you can use the command line to interact with buckets. We also have a JavaScript library. This is just the documentation for the JavaScript library for buckets. There's also a Go. The original implementation is in Go. We also have a not totally documented yet binary. So if you just want to run bucket nodes, you can do that, but we're not quite ready to support it, but you can find it out there. And then I wanted to just show you something I built this afternoon. I realized that our documentation was missing a good example of drag and drop for files on bucket. So here's that same folder of images, and I'm just going to load them in with JavaScript into the browser. So here it's creating a bucket. And what's really cool is it's actually pushing these changes to my bucket to a remote peer. That remote peer is going to persist them on IPFS for me. And then when I refresh this browser, it'll all just come back. And the way that it knows that they're mine and that it can get access to them is there's another step in here that it's creating a private key identity in the browser for me. So it's just mine. And I think maybe the people in this audience would be most interested in how we're doing some of that optimization for how data is moving. So if you're familiar with IPFS, you've probably come across Merkle DAGs. So it's the idea of sort of breaking all of your file structure up into these optimized tree structures. And so we use that in buckets, not only to get things moving around in IPFS, but we also use it to do some optimized diffing and syncing of data. So that's where I showed you, it just knew that one file changed. So when I go to push it to the remote node again, it only has to push that one file. It's pretty obvious stuff once you see it, but it's very cool. And this blog post will give you a really good rundown of how that's happening, and actually how buckets are going to interact with Filecoin in the near future. This gives sort of a sneak peek on that. Which brings me to the third piece of technology, which is the Power Gate. And I'm super excited to hear that there's a few people on the call today that have already been messing around with the Power Gate. It's just like, it's a really cool piece of technology. And if you've ever tried to stand up your own nodes on blockchain networks before, you know that sometimes it can be pretty painful, and the Power Gate, I think, just makes it so easy to get started. And so the Power Gate, for those of you that haven't been able to crack it open at all yet, it's an API-driven solution for developers to use Filecoin and IPFS together. And so we started looking at where Filecoin was going to be by mainnet, and we started realizing that there was a really cool opportunity to build a bridge between Filecoin and IPFS.
Well, it got mailed to you.
Sorry, what was that? To merge IPFS and Filecoin together. That wasn't going to be part of the Filecoin mainnet, at least at in the first launch or in the first releases. And so the Power Gate does a lot of cool things where you can store data in IPFS for network availability over the IPFS protocols or over HTTP, and you can persist it long-term in Filecoin, and you can map that data so that it can sort of more fluidly move between the two. And the Power Gate also does a bunch of other work for you that you kind of will have to do if you want to use Filecoin, whether you build this stuff into your own systems or you use the Power Gate to do it. And that's not only creating the deals and transferring the data to the miner, but that's also handling things like repair if one of your deals gets broken, or renewing it because deals have an expiration time, and a bunch of other things. And we can kind of talk about a little bit of that later if you're interested. I wanted to spend a little bit of time kind of giving an overview of what the pieces were in the Power Gate, because I think it's just such a neat piece of technology. So the first part is it's running on Lotus. So if you haven't been tracking the Filecoin development, one of the main implementations of the Filecoin node is called Lotus. It's written in Go. And so the Power Gate, when you run a Power Gate instance, it's actually going to run kind of three things. Well, the PowerGate isn't going to run any of these things. If you run, say, our Docker Compose file, it will stand up these three things for you. One is the Lotus node, and if you're running on testnet or in the future mainnet, that node will be tracking the full chain. So it's a full node tracking all the updates of the chain for you. The second thing is your IPFS node. So the PowerGate uses IPFS quite a lot, and so it needs sort of a node dedicated to its work. And the reason it kind of needs that node dedicated is so that it can manage the pin sets in there with some reliability. If you're kind of editing it from the outside, it can cause some issues. So it kind of runs these two nodes. And then you have the PowerGate, and I'll show you a few of the different pieces of the PowerGate, but the main kind of innovative piece in the PowerGate is what's called the FFS, the Filecoin file system. And the FFS is you can kind of think of it like the multi-tenant system in the PowerGate. You can create many FFS instances in your PowerGate, and each of those instances will get its own token that you can then access your PowerGate over its API, and it will have its own address, wallet address with its own balance. And so you can create transactions with your FFS. You can store and track data with your FFS instance. And so if you're building an internal system, this can be useful to break up what different services are using your wallet and your PowerGate in different ways. Or if you're building, say, a consumer application, you could have every user in your system map exactly to an FFS, where they would have sort of their own siloed storage system with their own set of balances away from all the other users. So what's really amazing about the PowerGate is just how easy it is to stand up. So here I'm just going to run the Docker Compose that comes in the repo. Here I'm standing it up. And we actually added here what's called the DevNet. It's an embedded DevNet, so there's no external network needed, and it will stand up. It's up to you. You can configure it for any number of miners that you want that will be embedded locally in your network. And this is really great because you can tune parameters of how that network runs. And so we actually use this to stand up our own network every time that we run continuous integration. So this is like amazing, because now we can build things really fast and actually test that it works on the network without having to run real deals on the network or deal with miners and how they might be treating our proposals. Instead, it stands up a fully local network for us with some key components that take a long time in the main blockchain, mocked. So sector building is, if you've been following this, it has mocked sector building is a good example of that. So it can just kind of move fast and stay lightweight. But you can do the same. This same command is just one word change, and you'd be connected to the main Filecoin testnet. But of course, then you might have to wait for your chain to sync, and your deals are going to take real time. So there's kind of two ways to run it. But so this is also awesome for just building things, because you can just stand it up locally, get all the API surface area, everything runs exactly like it would run on in the future mainnet, just a bit faster. And obviously not real persistence out on the network, because you can close this down and throw it all away. So the way the PowerGate is broken up conceptually is we think about it as cold storage and hot storage. And this is like any old, like any computer system where you've thought about moving data and you want to think about the different layers of caching, and it maps right to maybe your hard drive and your RAM. But the way we've thought about it is that cold storage is on Filecoin and hot storage is on IPFS. So everything on IPFS should just be available and ready on the network, whatever your definition of network is. And cold storage is stuff that's going to take you a while to get back out if you need it, just because those retrieval deals can take time. Everything in the PowerGate is API driven, so it's all exposed as a gRPC API. That CLI example that I showed you is actually running on the gRPC API. The JavaScript library actually runs on the gRPC API, so it's really an API thing. Lots of different commands in the CLI beyond just storing files. Oh, actually pretty interesting here, worth pointing out, is the PowerGate also builds up some sort of like network intelligence over time about who miners are. So what kind of deals are they creating? What's the prices that they're being quoted at? What's their reputation? Have they been slashed? Where are they in the world? And so you can actually, when you're creating deals, configure how to rank the miners so that you can just pick the best miner that fits your criteria and store data with the best one out there. So let me just jump forward here because I want to actually show you a bit about the FFS. Like I mentioned before, every PowerGate just manages one to many FFS instances, and each FFS instance can have one or multiple addresses in a wallet. So every file you store is tracked by your FFS instance, and every file you store is actually mapped by its CID. So that's its hash address in IPFS. And so when you store a file, you can either use your default configuration, or you can set a new configuration per file you create. And that configuration is really powerful because that configuration is going to do, like what I just mentioned, it's going to be used to select the right miner for the deal, but it's also going to change how this is stored in hot storage or cold storage and how it's going to change over time. And so this is every FFS instance just has its default. You can change the default, or you can do per deal configs. But I can just walk through a little bit of this quickly to show you kind of how powerful this gets if you start adding it all together. So in the top here, just the first 5 lines or so are defining how this data should be stored in the hot layer. So here you can see it's enabled by default. And then allow and freeze just means like, do you want this file to be retrieved out of Filecoin if it's missing from the hot layer or not. And then what's also really neat here is that add timeout. So the PowerGate can actually be, you can make it redundant by other things you're doing on the network, so that if it finds that it's missing something in the hot layer, it doesn't have to go right to Filecoin to get it back in the hot layer. It can actually go out to the network. So you have multiple actors that might all possibly be making that file available. The PowerGate will work with them instead of going back to the cold storage first. And then in the cold storage layer, you can see a bunch of things here. So by default, it's enabled. So every file you create is going to create a deal. It has some information about whether it will renew or not. Replication factors really like pretty neat. So you can actually just set that, like we were playing last night with setting a replication factor of 30. So it will pick 30 different miners out on the network when you push this file and this config to your FFS instance, and it will try to create 30 new deals. And then it will just sit there and work through getting those deals and eventually write the confirmations back to the FFS. And so this is actually just getting to that idea that it allows you to build some pretty powerful mixed networks where you don't have to have everything going to Filecoin. You can have a few set of nodes, or maybe even just one PowerGate where you're pushing the data to archiving on Filecoin, but you can supplement that with other nodes on the network actually just being IPFS. And if that data is available on IPFS, your PowerGate won't ever really have to go back to Filecoin to retrieve it back out. This is only 2 layers, so it's just hot and cold right now, but I think there's a lot of room to actually grow and to let developers customize different ways that the PowerGate can push and move data to other kinds of nodes, or potentially if you're building a kind of service that might not need regional support, you might not necessarily have to run a PowerGate in every region, but you can let the PowerGate push to different regions based on what you're doing. And so, yeah, this is just another quick example. Here, I'm just changing a parameter of this embedded DevNet using this big sectors flag that you saw at the beginning, which lets me now store large files in my DevNet, so I can really build real application flows here. If you're interested in using this, there's also a bunch of good documentation on our docs website. There's everything I showed you there, and then there's also a JavaScript library for the PowerGate APIs. So there's a pretty great tutorial from one of my coworkers on using the JavaScript client, and it will just walk you through all the way from running the Docker instance to setting up a small node application to then using the PowerGate JavaScript client to connect. And this demo is really cool because it has a little GitHub login, and every login on your demo app will map to one of those FFS instances. So that means that you could allow a GitHub user to log in and store data to Filecoin through your PowerGate. There's another really cool application out there that could inspire you. It's called the Filecoin client. And it goes so much further than that. It's a really cool application. It's an Electron app, but it's using that JavaScript client embedded in the Electron app, which is written as a little Express server, and then it's giving this entire interface for creating and storing and managing files on Filecoin. So it's super cool. And then there's just a bunch of people already out there building on it. I think that this slide's kind of old, so there's actually maybe twice that many already since we've put it out there, and that have already been building stuff. And so it's a pretty quickly growing set of people, and we've just been announcing more ways that you could take advantage of it. So I think this will grow really quick. These are actually all people that are just running the open source run it your own version. Just this morning, we announced support for hosted versions, and we have the bucket support for using PowerGate coming really soon. So definitely in good company. And you can find us on our Slack channel, and also if you join the Filecoin Slack, we're in there, and you can find us in there if you need any help with this stuff. So that gets me to the last thing that I'll mention kind of quickly here, which is the hub. So I mentioned at the beginning that one of our driving KPIs is sort of the cost of failure. So reducing the cost of failure for developers primarily. And with all of these protocols and all these different nodes and all these different technologies, it can be exciting to come and try to build with them, but it also can be daunting because of how much time you'll have to spend to just start building. And so the hub is really our place to give some of those developers a way to skip that first step and actually just start building and start testing. And so it provides hosted access to remote IPFS peers, to remote thread relay and hosting endpoints. It's an endpoint for you to push your buckets for IPFS persistence. And like I mentioned, pretty soon it's going to offer some really cool access to Filecoin through that bucket API. And so if you're looking to just build and you don't want to get too bogged down into these core technologies, the hub is a really great place to just skip that and start building right away. And then all of this is open source, so you can always kind of pull that back apart if you want to figure out how to run it on your own network, or if you want to run it on your home device or whatever it is. You don't have to be locked into this, but it's there for you. And that lock-in is like I showed this thing the other day. So my colleague wrote a blog post about the diffing and syncing in buckets, and in that he gives a preview of how buckets will work in Filecoin. And what is super cool here is that since we'll be supporting that in the hub, you could actually push a folder of data in a bucket to the hub, and then you could archive it on Filecoin. And when that happens, you're going to get the information for that deal on the Filecoin network back, and that will immediately decouple your sort of reliance on the hub. So we've sort of disintermediated ourselves from your storage, because you'll be able to store it on this network. You could close down your account, you could totally leave the hub, and you'd never have to talk to us again, and you could still get that data back off of the Filecoin network, which is super cool. So the hub is really just meant to be this sort of launching pad to get you all in there and building stuff. And so hopefully you'll find it a good resource to do that. And like the hub also does a bunch of like account and key managements for you, so that you can actually build the hub into your applications that you'll give your users, such that you can then give your users their own threads and their own buckets that they actually control. They encrypt on their own, and we do that through a bunch of different API key methods that you can read about in our docs. And I don't oh, there's actually an old little screencast, but you can read all about it there. And then the last thing I wanted to say before kind of opening this up is that this was just announced last week, I believe, the HackFS. So if you just go to hackfs.com, really big hackathon happening. It's kicking off in about a week and a half. Lots of really cool opportunities. If you have a project you want to build, we're pushing a lot of stuff for PowerGate and buckets and the hub to help you build stuff and just get your projects out there. And I think there's going to be a lot of really great projects to win, or prizes to win, and possibility to actually turn those into businesses and incubate them into new projects in the future if they turn out well. So definitely check that out. And again, we're on our Slack, and there's other people that are already submitting things on our Slack. So if you're looking for teammates or anything already, definitely jump in there, jump on the Filecoin Slack. And that's all I got for you.
Cool. That's awesome. Thank you, Andrew.
Yeah.
Very exciting. So everybody that's on the Zoom is on mute right now. And if you have a question, you can either type it into chat. There's also an opportunity to type questions in the YouTube live stream, and I'm keeping an eye on that at the moment. We get 7-8 people on that as well. But I would like to say, well, first of all, I think this is really, really awesome. I am just sort of getting my arms around all the textile components, and I was watching the Pinning Summit videos from May last night, and I heard Juan Benet, the founder of Protocol Labs and IPFS, mention that they're really looking at what you're doing with, I think it was Threads DB and maybe some other constructs. That's kind of their model for creating their APIs and their constructs. Is there anything you'd like to say about that, Andrew? Is in terms, because it almost seems like what the work you're doing with textile is almost leading some of the initiatives for Protocol Labs.
Yeah, I think the thing that he was referencing in particular was they have this they have the pinning API. So it's actually a pretty big challenge, like how you if you want to build things on IPFS, one of the most successful kind of services out there built on IPFS today is actually a pinning service. So there's a handful of different companies out there that you can sign up for an account and you can pin things remotely. Doing that orchestration of what you want pinned is not nailed down yet. And so what we've done with threads and buckets is actually built an abstraction on a set of pins to say, how can you track that? And how can you track a changing set of pins? So if you think about what threads are, you think about what buckets are on top of them, they're actually just tools to help you manage changing sets of pins. And then there's a bunch of things on top of that to change what you're looking at and explain what they are. But at the end of the day, that can be a really useful building block that then Juan was thinking, oh, maybe we can get that back into core IPFS so that all these different pinning services, or if you run your own IPFS nodes to be your own pinning service, you could take advantage of that same kind of pin management. And we're just kind of in the early days of talking about that. I know that they're really interested in it. It would be awesome for us because it's the kind of like, it's kind of the feedback, it's the kind of feedback loop that you kind of dream about, just being able to build things on technology and then get those ideas back in the technology and then build the next thing and kind of layer it on and make it better and better. And they've been just an awesome team to work with in that way, because I think we're always having those conversations.
Cool, thank you. Any other questions?
Yeah, I have a question. Andrew, great topic. It's kind of a fundamental question. We have a project going on in real estate, and the one area of pinning that I keep sort of hearing this kind of murky answer on is the confidence of the data, even in Filecoin. Well, Filecoin you pay for, but in other words, if you're pinning it, is it really going to be there later? And we have some data that's going to be pretty critical. And so my hesitancy is with IPFS, how are you, when you're saying you're giving clients or anybody's doing a pinning service, what are they doing in terms of explaining to the clients the redundancy that's built in?
Well, I think it very well. Oh, thanks for your question, by the way. It depends a lot on the service that you look into. So like I said, there's just kind of there's a handful of different services that are out there, and they all have their own kind of different account and sign up method and what you're going to get for that account. That said, I think that pinning services are pretty, you can think of them as pretty traditional kind of Web 2 kind of APIs. Like if you store data on S3, for example, it's the same kind of assurance. There's no real strong guarantee that AWS, there's no guarantee at the protocol or the data level that AWS is going to continue to store that thing those things for you. It's just a relationship you have with them with their account and what kind of agreement you set up. And so it's just worth looking. But I think that with Filecoin, we're gonna move pretty quickly to the next stage of that. And so I'm already seeing pinning services coming to look at Filecoin, and I've been chatting with some just today actually about they're getting their Filecoin nodes set up. And what's really cool about that is the sort of loop that I mentioned briefly in my talk, stored in one service, and take that deal and move to another service, and not even move the data, just move the metadata about that deal and get that data then served and provided through that next service. And we're getting really close with mainnet launching later this summer. I think things will start really clicking and making sense there.
That's kind of what I was wondering is when you had mentioned that, the talk about the pinning and then the interoperability with Filecoin, that's what I was hoping to see. Just because the whole concept of pinning something, even to IPFS, like, and then not having the backup on Filecoin and everything being so new in adoption, it's a little tricky with some of the clients with that kind of sense of security. It's still, so I appreciate your answer. It was perfect.
Andrew, what would you like to see from the community to, further the initiatives that you're working on at Textile? What might be some of the collaborative opportunities between the Desert Blockchain community and Textile? I mean, the Hack FS, I think, is a great opportunity, and we'll certainly take a look at that. Is there anything else that would be of value to you and the folks at Textile?
Yeah, I think that it kind of comes in two waves depending on the timing here. And so we're obviously in that early stage still. I mean, mainnet on Filecoin hasn't even launched yet, so we'll be in the early stage until at least after that. And I think during that early stage, it's communities like you exactly that you have your eye on the leading edge, and you're trying to learn about these things way ahead of the rest of society and even the rest of the technology community. And that's awesome. And so just having you test and build and give feedback is great. And really, one of the things that's sort of like green pastures right now is seeing how these technologies plug into the other technologies you already use and you already love. Like you mentioned at the beginning of our call, trying to run these things on Raspberry Pi. That is like the perfect example of trying to see how these plug in with the systems that we're already used to and we're already working with. And that's going to make people's eyes open up. And so just keep doing that and keep building and keep making things awesome and explaining that to other people so that we can bring more and more of the community in. For me, that's it. That's it for the next few months. After that, I think that we can quickly move on. We can sort of like plant a flag in sort of markets and communities outside of where we are now. There's an idea that I've been thinking about a lot lately, and I haven't had a chance to really write it down. But I've been maybe it has a better term, but I've been calling it the third leg of the stool. And I think that Filecoin has a really great opportunity to enable the third leg of the stool for data preservation and data protection. And so I'm really eager to work with organizations that have really critical data sets that right now they only have two legs of the stool. And the two legs of the stool that I've identified that most organizations are using are that they have copies of their own data sets and they put those data sets on cloud providers, on existing cloud providers. And I think that it's we're almost to the point where we can go out to most of these organizations and say that that's not a complete set of security, and that for a very low cost they could get the third leg of their stool, which is to store their data in decentralized network with cryptographic assurances that that data will exist. And that to me is sort of like the next really exciting direction that we're going to go. And so any of you that are working on those data sets or working with people trying to onboard them to this idea and figure out how we can start having those conversations and start building the metrics to show that this is possible in a viable direction for real data.
Well, along those lines, there's a lot of activity here in Arizona around healthcare and also genomics. And, you know, in fact, Professor Marchand, who's on the session with us, is a geneticist himself, as well as a legal scholar. So are you working with any healthcare providers at this point? Would that be of interest to you? You have a background in genetics and biology. Is that
So-
something
Yeah, I
that
mean,
would be of interest?
I'm super eager to do that. I actually did my master's also in epidemiology, and I was studying the genomics of viruses, funny enough. So I had a really nice meeting with my old master's collaborator who's still working on those things, talking about how we could get data sets like GenBank, for example. You know, these giant data sets of scientific outputs, how can we get them secured and stored? Not only that, like if you look at research in general, there are so many data outputs from research today. So you know, phylogenetics, creating different tree outputs, alignments of genomes, all those things are almost bespoke in the way that they're created per study, per research output that then they get stored maybe. And if they are stored, maybe they can sometimes be difficult to access for future researchers. And this sort of cheap network-based storage that we're possibly moving into could allow really cool products to be built for researchers to store and persist and make their own data available for lifetimes into the future. And that to me is super exciting. But I think that genomics more generally and just like family ancestry and those sorts of ideas are the perfect area for these technologies to move into very quickly, because I think that they have strong application and also it will really sort of open people's eyes to what's possible. So I mean, long answer there, but short answer is yeah, I'm super excited about those directions.
Cool. Yeah, somebody else that's on the session also has some experience in registry tracking of immunization and so forth. And I don't believe that person's involved with that area right now, but I know that there is a set of experience there. So maybe we can kind of put our thinking caps on and, you know, come up with some ideas that might demonstrate to the healthcare and genomics and so forth that this is a favorable pathway for the future for treating these big data sets and handling them and doing some cool decentralized projects. So, yeah. Anybody else at this point? I don't see any questions on the live stream on YouTube. I will mention that tomorrow evening, Thursday, at 7 p.m. Pacific, Juan Bennett of Protocol Labs is going to be doing like a live question and answer session on Filecoin, and probably be talking about some of these topics as well. And you can get some more information on the Desert Blockchain Twitter feed, which is Desert Block Hack. Are you going to be a part of that, Andrew, on that Q&A session?
Q&A tomorrow? Yeah, if it's the same format as they usually do, I'm usually there just trying to read all the questions and see kind of where people's interests are. They're often very a lot of miners are showing up to that. So if you are interested in getting involved in the mining, that's actually something that we don't do much work on, but it's worth pointing out that they are starting the miner sort of competition in the very near future. So you can actually start, if you are interested in running your own mining rigs for Filecoin, now might be the time to explore getting that started, because you might be able to contribute to the competition and potentially earn some early Filecoin rewards for getting storage committed to the network. But yeah, so the Q&A, I think we'll have a lot of people from the mining side, and then some of us from the storage and application side.
Yeah, and along the lines of what you've been talking about in terms of the breadth of the use cases and applications for textile, during the Pinning Summit in May, and you can find this on the IPFS YouTube channel, during some of the talks on the use cases and business opportunities, there was quite a bit of talk about pinning and enhancements to the pinning operations and how that's a key piece to moving forward. And there's also specific mention of how the textile constructs can enhance where the not only the state of the art of pinning today, but also the direction that pinning is going, which might be an opportunity for creating some cool business opportunities and use cases here. So, yep. Any other questions, comments? Well, this has been really, really eye-opening for me, Andrew. I really appreciate it. And you've given us a lot of projects to investigate, fail early and fail often. Thank you very much for supporting my failure.
Yep.
But so I'm looking forward to continuing to play around with the with PowerGate and ThreadDB and buckets and so forth. So I will wrap it up tonight because I think that pretty well sets the table for future exploration. I will invite everybody to next month. We will have blockchain and sustainability, and Professor Marchant and some of his law students from ASU will be on that session on the 4th Wednesday in July. You can sign up for that. And who knows, there might be some opportunities to investigate some of the constructs we've looked at today in terms of document management and so forth. ASU's law school is very much interested and has had some great programs on e-discovery, which is all about document management and discovery, and how do you handle, how do you track, how do you get all these different and adversarial parties together to agree on the same set of evidence and documentation and e-documents. So we might have some common ground there. But anyway, super, super cool. Appreciate your time. I know you're super busy, and this was very valuable. The presentation will be available tomorrow on Patreon. I think it becomes public around 7 a.m. in the morning or so forth. You can see it there. And yeah, just thanks, Andrew. I'm looking forward to continuing the conversation and seeing how the Desert Blockchain community and the set of technical talent here could start to play around with the tools that you've provided us. So
Cool.
Thank you.
Yeah, thanks everybody here for joining, and me and the team are here to help. So just reach out to us if you try any of these things and need help. And I'm always here, so hopefully I get to talk to you all again in the future, and we'll be at like bigger and more exciting things, and we'll all have built cool stuff to share. So till then.
Awesome. Have a good night, and the recording will be available tomorrow. Okay, cool. Thanks.